Well, hello, everybody. I'm presenting today as Checksum, my hacker handle, about outbound traffic filtering. I really like the keynote because some of the slides just played right into my presentation, especially the one where John mentioned if you're a small company, you probably cannot afford to have Splunk or some other fancy tools. So this is actually a detailed walkthrough of how to use tools you may already have to get to a better security state. Without those fancy tools. There are about 7, 8 or so pages when you print this, but don't worry, I won't be presenting all of them right now, but there will be a link at the end. So if you trust me, go ahead and click it and you can get the presentation right away. So the About Me slide, yes, I'm indeed a former commie out of Czechoslovakia. It's where I was born and raised. But now really I'm just a security guy on the purple path. And my favorite pastime is enjoying, making life for attackers a lot more difficult than it needs to be. So really, this is about why should you filter outbound traffic, right? Hardly anybody does that, but it's a powerful security control. I'm going to show you that. We don't do it because we don't really have an easy button, or we don't have the budget to get the tools to do that. I will discuss the logic behind the script, how to automate this, and we'll briefly touch on the results and some lessons how this applies maybe at your place. So this is a web application conference, so let's go through a web attack. Our players are ultra-secure Apache Strat server, and the developers believe they are secure because they follow every OWASP coding practice. So the code is legit. Unfortunately, the version of Apache Strats is not so good, right? Now we have the attacker in here at this IP who is going to find this, and through some enumeration, they will realize that there is a CVE and a Python script that can exploit this. This gives you actually remote code execution, and the attacker wants the server to connect back to him and give him interactive control. It's like SSH in reverse. You just ask the server, hey, come to me and give me control over you. On the wire, it's going to send an HTTP request. I redacted a lot of the exploit stuff. It's really going to, if the code executes, there will be a network connection coming from the web server to the attacker, along with the interactive bin bash shell. As John pointed out, firewall, right? We know everybody loves firewall. They keep the bad guys out, or so you think. Because the attacker is going to come to you on HTTPS, and you really need to allow that, right? If you want to have any customers on the outside that are going to visit your web page, you need to let them in, and also the attacker. So the exploit code gets on the web server, it gets executed. The attacker is going to set up netcat listeners so they can receive the shell on something on this port. And the server is connecting to us now, and now, let's do a quick poll. Who here thinks that the attacker is getting a reverse shell at this point? Nobody. Interesting. All right. So everybody else thinks that the attacker is not getting a reverse shell. Right? Well, it really depends on the outbound traffic policy that you have. What is port 31337? It's the lead port, right? Do you have business applications that use that to reach out? Well, so why do you allow it? Now, I also want to highlight, this is an incredibly powerful detective control, because if you understand how your application behaves, and you know that the server never reaches out to the internet, if you get the alert on the firewall that it's blocked and the connection was attempted, that's probably something you want to look into it, right? So our mission is to deny everything, right, in and out. Unfortunately, the de facto standard is we are pretty good at blocking inbound, but we kind of suck at blocking outbound. Just allow everything. The better way would be obviously to block everything in and out and only allow the known good. Let's pretend we live in a perfect world. So you have well-defined perimeter, you have all the tools, knowledgeable admins. Anybody works at a company like that? No? Okay. I was about to ask if you are hiring, if you do. So in the real world, right, you're like, perimeter, isn't that something that we used to have in the 90s or something? NetFlow, I don't even know what it is or where to collect that. It just, by the way, NetFlow is aggregation of your network connections. Kind of tells you who talks to whom, for how long, and when and where. Your critical business processes, right? So you come home to your organization and you say, hey, I heard this crazy Czech guy talking, we should block all outbound traffic. And you roll with it, and it's like, okay, let's do it. And then a month later, your business process breaks that exchanges data with your partner. And you're not going home a hero. If anybody here looked at just running Sniffer on their workstation, if you don't do anything, you see a lot of outbound traffic already, right? So on an enterprise scale, there'll be just so much data. That's where Splunk and other SIEM solutions come in play, but they charge you because they know how voluminous it is and how difficult it is. And really, nobody has time to do extracurricular activities, right? Some tips on how you can overcome these would be, well, if you don't have the NetFlows or the tools, let's look for an alternative data source. If you have a firewall, it most likely can log the traffic that it sees, and it can send it to a syslog server, which is just an install on any Linux. So there is really a minimal cost in getting this done. And if you look at it, which we'll do, you can then get to where a commercial tool or even open source tool can get you. You can get yourself with just a little bit of creativity. For the critical business processes, if you analyze at least, let's say 12 to 18 months worth of data, you should probably see everything. If there is a process that launches every 2 years, maybe you will miss that, right? But hopefully it happens at least once a year, so you can document that. If you don't have a tool, you need to write your own, right? And obviously PHP is the tool of choice for everybody. I do want to give a shout out to my buddy Mark Montgomery. We used to always argue whether Python or PHP is better for this task. He was obviously wrong with Python. PHP is the better choice. And as you have too much data, you just need to focus on what is the bare minimum of data that I need to make the determination. And then just get rid of the rest. You cannot boil the ocean, right? To get time, what you may try to do is, Friday, 3 p.m., the last 2 hours in your workday. Well, let's be honest, nobody really does all that much productive work. What if you make that your R&D time, like research and development, and you just say, okay, I'm officially off work, I'm working on this and building something. So when we are done, we hope that nothing breaks, right? We know our outbound traffic IP and ports combinations. That may include some agents or your business-to-business transactions, call homes. For everything else that you cannot easily control, like web, because how do you filter web, right? You need to allow that to people. You can channel them through a proxy, like Cisco Ironport or Squid proxy or Blue Code. Because if you do, that gives you an inspection point, right? And you can get additional capability like domain reputation and stuff like that. Also, you may be wondering, well, it doesn't apply to me because we are cloud-only organization. Okay, well, you still have a perimeter, right? You probably have some servers that are, or information at least, that is sensitive, and it would be a bad day if it walks out. The method will be different, but it's really the same. You can look at what the outbound connections are and block everything. Or you can scale it down to a network enclave if you have large enterprise and just like, okay, I cannot block outbound because it's just too much. How do we get there? Let's find the data source, find the most relevant stuff. And John alluded to it in the keynote. You need to start small, right? Because there's so much data that you just cannot do it all at once. So let's just test your theories and slowly roll it out. So now we're getting into how to actually get the data. Like how do you go from these theoretical concepts that, yeah, we should filter outbound traffic into actually getting there? Well, let's set up a Cisco ASA firewall. It sends log messages to the syslog server. and you start to look at the syslog messages, and you're like, huh, I don't know, like, is it even English? It's just telling me something. May I recommend that you read the fine manual on Cisco's website. It's going to talk about all of these codes. And there's also google.com website that, if you know, it knows everything. You can find all your answers there. Then you start looking at the manual from Cisco, and you're like, yeah, that's worse than CSSP book on reading. It's just not doing it today, right? When you look at your syslog server, then you realize there are 100 different ASA codes each hour, and you're like, okay, you must be smoking something that you are not sharing, right? So what you can do is, again, you're coming to it cold, like you don't really know how it looks. So let's plant a needle in the haystack, right? Let's generate an outbound connection from our premise into the cloud. So there's a beautiful shade of posted yellow is a Kali living in a cloud, and there is a Netcat listener. Netcat is just a kind of universal network connectivity tool that you can do cool things with. The baby blue color, it's our ultra-secure Windows Millennium that lives on premises, right? And yeah, don't use Windows Millennium. But if you have it, I don't even know if Netcat works on it. So you make the connection outbound, connect to the IP, you send some text so you can generate traffic, and you close the connection. Next, you go to your syslog server, and now you know the time when you did it, so you can narrow down, into a small window. And you know that you connected to port 4444. So hopefully you don't see too many connections. That's the Metasploit default port. Hopefully you find only yours. And now we are getting into the, is this even English? Just like wall of text doesn't make any sense. If you read a little bit, it's telling you the connection was built outbound. You see the IP and the port we connected to and from which. There is some connection ID that will be helpful later. You get another hit on that search, and that is when the connection was destroyed, when it was terminated. This one tells you how long it lasted, how many bytes were transferred, and other stuff. This is the reference from the ASA manual, and they explain each of the fields, like what it actually means, so it makes it easier. This slide is really just the same, just helping you visualize your internal network with Windows Millennium going out through the internal interface into the external interface and out into the cloud. So this was the posted yellow, baby blue, and the log message is generated in here. Before you start jumping to conclusions that now you know what to look for, how does the log data look like, I would recommend that you test your theories just to make sure that it's correct, right? So let's generate some inbound traffic, which is we just switch the roles. Kali is living in the DMZ in our organization, and in the cloud we have Windows Millennium connecting to the DMZ. So this will be inbound connection for us. Let's send some traffic and look at the log at the syslog server. You can kind of see that the message really is the same. There is one subtle difference, and that's the connection was built inbound. But the order and like the IPs and stuff, it's pretty much the same. So that's a little bit of a challenge, because if the teardown connection doesn't tell you the direction, you kind of need to do some magic behind the scenes to get that. This is again the same visualization. Some other things to test. What does that look like on the UDP side? What if, is it the same ASA code? Is it different? What if you have a rule that blocks the traffic on the firewall? And how does that connection look like? Or syslog message, or if the IP doesn't exist, right? So I already mentioned there will be a lot of data to parse through, and you are building a homegrown script, so you don't have an enterprise class tool. You need to really minimize what you collect. Just get the bare minimum that you need. And the messages have most the same information. So which one do you get? Do you get the build out or the teardown message? You need to get both, because the build out has direction and the teardown does not. But the teardown will tell you was the connection successful, how many bytes were transferred, how long did it last. And if you get only one, where do you get the time? From the initial connect when it was built or when it was turned down? So I don't recommend you collect both of them, because that's duplicating the amount of data. And how you can actually parse it. Now we're getting a little bit into the implementation details. And again, the notes go into great detail in more concepts behind this. As you parse your syslogs, looking for outbound connections, let's build an array or associative array. It's called a dictionary in Python. And you're looking for connections crossing the external interface because you don't need internal to DMZ. That's outbound as well from inside to DMZ, but that's still your network, hopefully. So you build the outbound and you use the connection ID as the key in the array. And then you read all the teardown messages, again using the connection ID, and then you can call what's called an array intersect, where essentially it takes the two arrays and it will crop the larger one, leaving only the elements that are in the smaller one. So you're going to get the teardown, more valuable information, but only those that are outbound. The unique key in these connections, per the documentation, it should be unique, but I did figure out there was an obviously inbound connection in my data set for outbound only, and I was just wondering where I made the mistake. So when I looked at the log files, I realized that I had a TCP and UDP connection with the same connection ID, which wasn't a problem for the firewall, because it keeps it separate, right? But it was a problem for my script, because I just picked up the teardown message for the inbound, not the outbound. So to combat that, you can add the protocol into the connection ID as the key. There is always the source and destination interface, and if you ever worked a firewall ticket, you know that people just don't get those straight. For some reason, it's confusing, right? But then if you look at the syslog message, which one is the source, which one is the destination? And is it the same for inbound and outbound? Would you imagine that the inbound and outbound, does it switch the position or not? In this case, actually, it does not. For outbound, the first one is destination, and the second one is source, and for inbound, it's the other way. But it's not even important right now because you're just carving out the data, and you can call it interface 1 and interface 2, right? And then build some logic later on after you figure out what it is. Because if you start calling it source now in your script and data set, and it's the destination, then guess what? You need to go and change all of it, right? A pro tip, use 64-bit because you will overflow 32-bit architecture pretty easily. 4.2 billion is not enough. We do have some tips on parsing, actually, and this is not a PHP talk. So there are just some functions. You can use the programming language of your choice, look for an alternative in there or similar function. This is some tips how you can extract the data out of the syslog. You are now carving out the data, and you're just getting IP address and a port. Well, can you enrich that, right? Because IP address doesn't really tell us anything. So you can do some ASN and whois lookup and geolocation. You figure out who owns the IP, because that may be interesting. Like, are we talking to the Czech Republic, and for what reason? You can also do NS lookups on those IPs. Just be mindful that if you resolve a DNS name that's unique to you in a campaign by an adversary, it may tip them off that you know about them, right? So, but it's nice to know the domains. Regarding the date, I'm just, you have the date time, but how do you run queries on show me all outbound traffic to port 444 that happen every second Thursday in a month? You would have to go through essentially all the timestamps, carve out the Thursdays, that's every second, and then it will be really slow. So I just split the date and say, okay, this date was Thursday at this hour, this day of the month, and this makes the querying of the data faster. As I said, there'll be a lot of data, so you realize pretty soon that you cannot keep up by doing the information enhancement, because one thing is taking even large volume of data, extracting information, saving in a database. The other thing is if you start doing whois lookup and DNS lookups, all of a sudden you go from nanoseconds to milliseconds, or maybe more, times hundreds of thousands of lines or millions of lines. And my initial iteration of the script was going slower than the real time. So I was like, okay, I will never catch up. So I changed it that I just extract the data and then run a second script that parses that and does the enrichment. Also, as I said, you just cannot do it all at once. So let's look at the chattiest protocols. Probably DNS and web will be most of your traffic leaving your organization. Well, let's just ignore that. Maybe you have the proxy that it goes through, maybe not. We can get to it at some later point, but it's just too much data, so let's get rid of that. You may have some cloud presence and you have on-premise scanner. So it does a port scan, and guess what? You see, all the ports being hit outside. Is it all needed? No, it's just the scanner doing its job. So if you know what IP address that has, let's just not collect that data. And if you know about the transactions, then you should definitely not collect those, because if it's known good, then it should be allowed and you don't have to worry about it. Just a simple ignore list. The first line really says, if the protocol is TCP or UDP and the port is 80, 443, or 53, so that's web and DNS, I don't care. Right? I'm not collecting the data. Just drop that line. So to put it all together, you need to go and get the syslog file from the syslog server, and syslog usually rolls every hour, and then at the end of the day, it compresses the data, moves them to a different folder. So I start my script at 1 a.m. to give the syslog time to do whatever it needs to do. I collect the data, parse it, find the outbound connections, extract the IPs, save it, do some enrichment, and now it's time for you to shine by building a cheesy web GUI. And I'm not a graphical designer or a web developer. I'm a scripter. My scripts work. I don't have to look pretty. But this gives you, because now you have the data, all outbound connections. Well, how do you search through it? So you can search by source or destination IP or by the protocol. You may not know what to really search for. There's a filter for date, because again, if you collect for a long time, you will have large data sets. You can put some tapes how to use it, how to use wildcards. And then you present the users with results, right? So this actually line is discussing or showing the connection we made from our Windows ME host to the Kali. And you now see the data enrichment, because previously we just seen the IP 107.77, but now we know it's a cloud provider in Texas. Okay, kind of good. We also know that the source was the Windows Millennium host, so that kind of tells you, okay, I know where to look. And you know the data has been transferred, so that kind of tells you, well, did we just lose some data, right? Then you start looking for other 444 traffic, and you may find other interesting things, like, for example, your pwned host or your domain is talking to the Czech Republic, and the company name happens to be Hackers for Rent. So do you have a problem, right? You can find another data set, and that's just telling you that somebody in Oklahoma was not successful. As we all know, OU sucks. And then you can get some of the UDP traffic. Now, that link, the script generates an Excel file, because this is 4 lines, so it's easy to analyze. But if you get back thousands of lines, you want to put it in Excel and do some analytics, pivot tables, and other things. So now you have an interface that can query the data. What are you going to ask, right? Which questions are you going to ask? Suppose you get an indicator of compromise that says, if you see this IP and this port, it's probably bad. Now you have interface to go and look. But even better is, if you carve out the statistics, then it's kind of going to help you narrow down the search on, let's take, we now know that web and DNS are just too much. We are not looking at that. Let's find the next most shadiest protocol or destination IP and look into that. So I'm going to extract the statistics overnight, because it takes a long time to pull from large data set. And then you publish it to the user so they can do some informed queries on this. And my initial thought was, okay, what is leaving the organization? I'll be generous and let's say 200 different protocols. There are 65,000 on TCP and UDP. And then I look, after 18 months, we are hitting more than half of those. And just like, well, what the hell is going on? And then you see the non-FTP ports. FTP data channel is just extremely chatty and horrible, and it's hitting almost all of those ports, right? On the unique destination IP count, again, these are the unique numbers, right, pulled from the database. Excluding web and DNS, I think it's actually a pretty small number, because over 18 months, out of the 4+ billion IP addresses, you hit only 56,000. Okay, that's maybe not bad. This is really interesting, right, because this is telling you what is the most common protocol that you see outbound. And number 1 over there is 8443. So that looks like an alternative web port. Well, but is it an agent? Is it, what is that? You can also look at, when you see the counts, notice that like number 1 is quite ahead of number 2, and then number 2 and 3 are together, but number 4 is half of number 3, and then you see the big drop-offs. On the UDP side, look at the bottom, you see 16, 3, 8, 4, 5, and 6, and the count is almost the same. That looks kind of interesting, right? And is number 16 83 or 87? So now that you know this, you can actually go and look for clues and figure out what this is. Some other stats you may want to provide is, the ChatDS source system. So you see that your conferencing audio-video systems are the ChatDS, and they are talking outbound. And you may think like, okay, it lives in the conference room. That's where we discuss maybe sensitive stuff. And the thing is connecting outbound all around the world. Is that supposed to be there? Is somebody else listening? Do you have a member on the call that's silent? Then you can look at, if you have a mobile user base and they go across the floors, they go home, they go wireless, they keep changing IPs, but one of them is like among the top 5, does it mean that, like, what is it that they are doing, right? Why they're so chatty where everybody else is not? And you can see some servers and other stuff. On the destination side, this is what's going to highlight the business-to-business data exchanges that you may want to pay attention to if they use non-standard port. You can also see that there is a lot of cloud traffic because everybody's in the cloud, and so there is a Cloud9 provider that we seem to hit quite often. Your guess as to which cloud provider that is. I also like to look at the other end of the statistical analysis. So I looked at which ports and IPs were connected to or hit just once or up to 3 times. And the data is actually pretty interesting because on the UDP side, we had 33,000 unique UDP ports, but a third of those has been hit just once. And I'm like, what the hell is that, right? That just doesn't make any sense. And then if you look at the destination IPs, we had 56,000. So that's a little bit over half that's been hit just once. So what is that? Some conclusions on the statistics. We do have the bad. The good is relatively small number of IPs. The bad is that we hit half of the ports, so there will be no easy deny. And the ugly, of course, that's the FTP, right? Because it's just horrible protocol. But also those 11,000 UDP ports that were hit just once. I just hope that it's one source IP that's responsible, right? Because I can find it. Otherwise, good luck chasing that down. This is also important. I told you how you can get the data. And you know that port 8444 was your number 1. Well, what is that? How do you get there? If you have a network tab on your perimeter, you can build some BPF filters and run TCP dump and look for that traffic. Then when you collect that, you can use Wireshark because it has protocol analyzers, and you can maybe figure out what it is. If you don't have that visibility, or to augment that, you can also use endpoint detection and response tools like Carbon Black, for example, or something else that can tell you which process made that connection. If it is word.exe, probably okay. If it is checksum.exe, perhaps you want to look into that. And if you don't have tools like that, you can just use the native logging on the OS. So Windows Event ID 5156, you can collect that and extract the data, or turn it on Linux auditing. You can also think about, you have a workstation that sends interesting traffic. Well, you can set up man in the middle or use burp if you have local configuration, if it's maybe web traffic, and then you can see what's going on. And let's not forget that you can also talk to the user, right? Like you can be like, hey, I see interesting traffic coming out of your workstation. Can you tell me a little bit more about that? As you go and do this analysis, I recommended you take notes, right? And I put it on the website as well, where if somebody is looking at the 8443 and 9573, those were like 2 in the top 5. That actually happens to be WebSockets. So when you visit like the go.com domain for ABC and affiliates like ESPN and everything else, you may connect through a web proxy on port 443, but then there is a WebSocket channel open on port 8443, and that's quite chatty. Now, does your web proxy understand that? Is it going through it? Do you have any visibility? Because you have one connection that's maybe filtered and inspected, and the other one, who knows? The Cisco, these are all like Cisco WebEx ports. The conferencing equipment in your conference room, that's why you see so many of those ports. They're all tied into that. And again, I would say, okay, if I understand what it is, and I know that I need that, then I can allow that on the firewall and remove it from my data collection, and then drops the volume that you are collecting. And if you know that you don't need it, then you just block it and also start ignoring it. The Teredo protocol, you may have an organization that says, we don't do IPv6. Actually, who rolls IPv6 intentionally? Hardly anybody, right? But you all roll IPv6 without you knowing that because it's just there. And Microsoft has Teredo tunneling protocol that is using port UDP 3544, and it talks outside and is looking for IPv6 routers. And IPv6 route is typically preferred by the OS over IPv4. So you may set up all your controls in here, and your systems are going through there. Do you have visibility in IPS or IDS? And then you find some other weird stuff. So as you go through this, again, your goal is to filter everything outbound. So the first step is knowing what you have. As you go through the exercise of figuring it out, you find port 8444, maybe it's WebSockets, run it through the proxy, and block it. And stop collecting it in here. If it's a known bad, then just create a block list or deny list, and maybe you want to investigate why is it making that. Is it just a call home that you don't need, or is it some pre-compromised Docker image that it's running? One of the interesting thing for me was you've seen the TCP port. We've seen like 55,000. But of that, about 20,000 or so were just tied to FTP. And you'll be like, oh, wait a minute, FTP, that's port 21 and 20 for the data channel. It's like, well, not quite, right? So you have the control channel, and as you transfer data, it's opening random ports on the server, and you're connecting to those and exchanging data. But because you don't have visibility into the control channel in your syslog, how do you tie all these flows into that FTP control channel? And I'd go in length on discussing the logic behind that. So, this is just what this slide is about. The things you may find, I kind of touched on that a little bit already. You have WebSockets. Like, do you know what WebSockets are, right? Like, how do they work? Are you inspecting that if you're looking at outbound web traffic? Your IPv6, you may think that you don't run it, but, think again. For the personal emails being mapped to your corporate Outlook, I'm not discussing whether it is okay per your company policy, can you do it or not. But think about it this way. You may invest heavily into email security controls. You put some advanced threat protection stuff and bunch of filtering. And then a user checksum maps their personal email to a corporate Outlook, and you're now opening all the emails and attachments on your endpoint. So all your email enterprise controls are being ignored. So if you see that, you can go talk to him and be like, hey, what are you doing? Some parting thoughts. John in the keynote alluded to it. You may have some cool tools, and if you do, then definitely use them. I did say that we don't need any NetFlow, but if you have it, I'm not saying NetFlow is bad. It's actually really good. You should be collecting that, but maybe you don't have the ability to do so. So if you don't have that, you can just go and script your way away. In our field, I highly recommend for you to learn a scripting language. It doesn't have to be PHP. It can be Python or Perl, PowerShell, whatever else. But you need to help yourself get through the voluminous data. Find where the data is and look through alternative locations, because again, you may not have a fancy SIEM tool that has all the answers for you. But you can pull maybe a log from an application or a device that can kind of tell you about that. And of course, if you find some good data, then extract that, see how you can enrich that and analyze that to get you a step closer. And any automation is, of course, awesome. And don't be afraid to just ignore the data that you don't need. You really need to be like cherry picking what you need. All right, I know it's lunchtime, so as I said, that QR code will go to the short URL link right there. I tried it before the presentation. It opens this as a PDF file in OneDrive. I promise. Well, so your NetFlow, the firewall really doesn't care what protocol it is, but you will see it going on port 80 and 443, right? So you will see the connection in NetFlow, but you may think that it's a web traffic where it may be DNS. And that's why I have the slide on, if you start looking at it, figure out what it actually is. Try to sniff the traffic or look at the endpoint. I know it's reasonably new technology, but it really doesn't change the equation. You may just be blindsided. And keep in mind that we are not looking at everything. So if the attacker is going to choose port 80 for outbound shell, maybe they get out, right? If they go through a proxy, maybe they need to have a proxy ever shell, and it's a little bit difficult. But anyway, any other question? All right, well, thank you.